Okay, so yesterday we did proving triangles similar, but we only did phase one. This is phase two. We're gonna add another theorem slash postulate and go from there. All right, so just a quick review from yesterday. Two triangles are similar if they have two congruent angles. All right, so what does that mean? Well, like looking at this right here, triangle ABE and triangle CBD both have these set of angles that are congruent by vertical angles. All right, so I can say angle ABE is congruent to angle CBD because they're vertical angles. Furthermore, I got some parallel lines. So I think yesterday we saw corresponding angles. This time today, guess what I'm going to see? I'm going to see some alternate interior angles, all right? And then alternate interior angles are congruent. We have parallel lines. We can say that's the transversal, so on and so forth. So angle AEB is congruent to angle CDB. Because they're alternate interior angles. And then lastly, I could even write a similarity statement if I would like. I can say, oops, by angle. So this is kind of a good review of saying, well, angles are congruent in similar triangles. Angles are congruent, sides are proportional. All right? So angles congruent, sides are proportional. So recalling the SAS theorem from yesterday, well, we have the included angle. This is an included angle because the side we're investigating create it. Furthermore, I can set up I can see if sides are proportional. There's multiple ways I can do this. I can say, let's just do small number over big number. I'm going to say, well, what's 1 over 1.3? I have a trusty calculator, and it can tell me, ooh, this is kind of some funky number. It's about 0.769, all right? And then I can do 3 over 3.9 in this triangle right here. Again, small over big. And I'm suspicious that it will be the same thing. Yep, identical. It's about 0.769. All right, so sides, remember, sides are proportional. And again, we'll elaborate on that. Sides are proportional, angles congruent. That's what it is in similar triangles. And then in this particular one, I can say triangle ABC is similar to triangle EFD. All right, that's a similarity statement. Again, remember, we'll just look at one angles, but C and D are congruent. Those are the corresponding ones, so they must match up in the similarity statement. So that's a recall from yesterday. AA and SAS. Now we're going to recall, we had the SSS congruence postulate. Again, that was in unit 4. And what this said, well, if I have two triangles and all their corresponding sides are congruent, then the triangles themselves must be congruent. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Similarly, pun intended, smiley face. Similarly, there is also an SSS similarity theorem. All right, so if three sides of one triangle are proportional, remember, sides are proportional. I said that a bunch already. To three sides of another triangle, then the triangles are similar. Now, what does this mean? What does this look like? Well, we got these two triangles. We got this triangle chilling over here. We got this triangle chilling over here. Well, we got the similarity statement. Let's just match up the corresponding sides, divide them, and see if they are in fact proportional. All right, in this first one, we're going to do AB over XY, 4/5 which is 0.8. Next, we're going to do BC and YZ, which this one, hard to tell, but this would actually also reduce to 4 over 5, or more simply, you could bash it into a calculator and get 0.8. And then the last one, AC and XZ. AC and XZ, we got 8 over 10, which is 0.8. So it says, is the triangle similar? We say yes. Triangle ABC is similar to triangle XYZ by side, 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 similarity theorem. All right, that's it. That's the punchline. All right, let's just do one more to emphasize things. Again, 4, 6. And this next one is going to be 6 and then 9, and then 7 and 10.5. Those are all the corresponding sides, and you can just set up these fractions and say, well, do they equal each other? If you have skills at reducing, that helps. But if you don't have skills at reducing, maybe you just need to plug it into a calculator. And it's 0.6 repeating each and every time. 0.66666666667. That's what your calculator will say. But yes, all the corresponding sides are proportional. Thus, the triangles are similar. All right, stay